Hello everybody, and once again welcome to Pankaj's Echelon Tutorials. Today we are going to start with a new series, kind of, and this I would call as a chemistry revision. In this chemistry revision, since the examinations of the IGCSE boards is just under the nose, so students must be struggling with some of the concepts, some of the difficult ones. And for that purpose, I'm going to prepare small videos on particular concepts in chemistry. And, this can be helpful to the students during the crucial examination hours. Okay. So let us get started. And today I'm going to start with uh, the concept clearance of this chapter called acid, bases and salt in chemistry, and this is chapter number 3, I suppose. And from this chapter I have chosen a topic called indicators and the pH value. So I'm going to make clear about all this concept and misunderstanding, if any, about the pH value and the indicators for the students, right? So that they are benefited, right? So let us get started, and let us talk about pH value and indicator. So what is a pH value? Now pH value is something which will tell you about the nature of the solution that you are dealing with. For example, suppose you have a solution, okay, and you want to check whether it is acidic or neutral or basic, okay. So to check the nature of a given solution, okay, whether it is basic, acidic, basic or neutral. See, it can be either acidic, basic or neutral, right? So to check whether the given solution is acidic, basic or neutral, we can use the pH value scale, and we can tell whether a solution is acidic, basic or neutral. Okay, so first we should understand what is the pH value scale. Now this pH value scale starts from 1, okay, and it goes up to 14, right? So you can say from 0 to 14, right? So pH scale is a scale which runs from 0 all the way to 14. Okay, so you can have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. Okay, so this is your pH scale, right, from 0 to 14. Now this pH value of 7 is very important. This will indicate that these solutions are neutral. So solution with pH value 7 is considered to be neutral. Okay, for example, water is a neutral solution. It's neither acidic nor basic in nature. All the values below 7 will be acidic in nature, and all the values, pH values greater than 7, will be basic in nature. Okay, so this is what a pH scale will help you with in deciding whether a solution is acidic, neutral or basic. Fine, but then how you will come to know whether the solution is having pH value of 7 or a 2 or a 3 or a 13? So this particular thing can be done with the help of something called indicators. right? So indicators are something which will tell you whether a solution is acidic, basic or neutral with the help of a different criteria. With a different criteria, it will tell you whether it is acidic, basic or neutral. Indicators will tell you that a particular solution is acidic or basic or neutral by the change in color. Okay, so that is another way of checking whether a solution is acidic, basic or neutral. And one way is of checking with the pH scale. Now we get a ready-made pH scale meter. Okay, they call something called pH scale meter. This pH scale meter are instruments, okay, which will directly tell you the pH value of a solution. So suppose you have a solution in a beaker, okay, all you have to do is there's a pH meter over here. This is a pH meter, you can kind of, okay, this is the display of the pH meter, right? Now you can just dip a electrode, okay, you can dip the electrode into this solution and directly this pH scale meter, this is a pH scale meter, this will automatically display the pH value of the solution. Okay, so whatever is the pH value of the solution, it will be flashing over here on the display. Now suppose the pH value flashing over here is 3, it indicates that it is acidic in nature. Suppose it is 1, then it is a very strong acid. Suppose it is 2, still it is a strong acid. But if it is 5 or 6, it is still acid, but it is a weak acid. Suppose it flashes 7, that means it's a neutral solution, it's neither acidic nor basic. And suppose it flashes 8 or 9, okay, then it is a very strong, very weak base. And if it flashes 13 or 14, that will be very strong base. Okay, so this portion, that is extreme right portion, indicates strong base, right? The extreme left readings indicate strong acids. Okay, this is how you have to classify into strong and weak acid base. Okay, now these can be considered as weak acids and these can be considered as weak base. Okay, so that's about pH scale. I don't want to go into the definition of pH value and all that, how it comes, what is the meaning of that pH value, what it indicates and all that. That I don't want to go for it. Just you should understand that pH value will tell you about the acidity or basicity, or whether the solution is neutral. That you can come to know from the pH values. Fine. Now let us talk about the indicators. Okay. Now indicators are nothing but chemical substances, like any other chemical substance. Indicators are also chemical substances. They are compounds, right? Now in your IGCSE curriculum, okay, you will have to study the following indicators. One is something called litmus paper. Okay, another one is something called methyl orange. Third one is something called phenolphthalein. Now phenolphthalein, the spelling you have to be careful. PHENOLPH PHALEIN, phenolphthalein. And then you have something called there's one more, methyl orange, litmus, and you have something called THYMOL, sorry, THYMOL, PHALEIN. So this is pronounced as thymolphthalein. Okay, this is phenolphthalein, this is thymolphthalein. Okay, now litmus paper is in general purple in color. Okay, methyl orange is orange in color. Phenolphthalein is colorless, and this thymophthalate is also colorless. Okay, now what happens when these indicators one by one are added to solution, and if the solution happens to be acidic, what happens, and if it is basic, what happens? Okay, so suppose the solution is acidic and you introduce this litmus paper into that solution, then the litmus paper will be turning red. And if it is added to a basic solution, then it will be turning blue. And suppose if it is a neutral solution, okay, it will not show any change in color, it will remain purple. Is that clear? The original color, right? Purple. Fine. Methyl orange. Methyl orange is originally orange in color, but when it is put into an acidic solution, okay, what happens is it gets converted to pink color. And when it is introduced into an alkaline solution, it turns into yellow. Okay, from orange to pink, from orange to yellow. And if it is put in a neutral solution, okay, it will remain, it will show its original color, that is orange. Fine. Phenolphthalein, it is colorless originally. When you put it in acid, it will still remain colorless. But the moment you put it in a basic solution, okay, or you can say in an alkaline solution, right, it will get converted to pink. Got it? And in the neutral solution, it will remain colorless. And coming to the last one, that is thymolphthalein. This is originally colorless, okay, but the moment you add it to a acidic solution, okay, this will again remain colorless, same as phenolphthalein. Okay, it will remain colorless in acidic solution, but in a basic or alkaline solution, it will turn blue. Okay, and in neutral solution, it is going to remain still colorless. So these are the various change in color that you can observe when certain indicators. I have mentioned over here 4 indicators. Okay, litmus paper, methyl orange, phenolphthalein, and thymolphthalein. Okay, these 4 indicators will show this kind of change in color when they are introduced into either acidic, basic, or a neutral solution. So depending on the change in color, you can tell whether a particular solution is acidic, basic, or neutral in nature. There's one more indicator which is known as something called universal indicator. Let us talk about that as well. Universal indicator. Now, what are these universal indicator? Okay. Now, these universal indicators, okay, they are something which will directly tell you the pH value. Okay, so universal indicators, they will indicate, okay, because they are telling you the pH value, they will indicate the strength, okay, or the pH range. If not exact, they will tell you the range, okay, the pH range of acidic, anacidic, or a basic solution. Okay, so this is what universal indicator does. It will indicate to you a range of pH, okay, say from 2 to 3 or 2 to 4 or say 5 to 7, something like that, okay, or say 8 to 10. So it will give you a certain range of pH value. It will indicate a range of pH value. From that range, you can, I showed you that pH scale, okay. So this scale, pH scale, right? So depending on the pH range that is shown by the universal indicator, suppose the range is showing from 1 to 3, it means it is a strong acid. But if the range shown is 12 to 14, okay, then it is a strong base. If the range comes to around 8 to 10, then it is a weak base. If it is 4 to 6, it is a weak acid. So depending on the pH range, the strength of the acid or a alkaline solution, the strength of the acid or alkaline solution can be determined. So that is what it does. And it can be used also for determining the strength of an acidic or an alkaline solution. So this, because it is telling you about the pH range, it is showing you the pH range, okay, you can tell not only whether it is acidic or basic, but you can tell also whether it is strong or weak, okay. Then it can do one more thing. It can also differentiate between acidic or a basic solution of different pH values, okay. So suppose you have two acid solutions, okay, suppose you have two acid solutions, right? Then using this universal indicator, you can differentiate between the two acids, whether the pH value of this acid is something else and whether the pH value of this acid is something else. Suppose the pH value of this is say 3 and this is say 2. So this can be also done with the help of this universal indicator. So it will help you in differentiating the pH values of the acid or the basic solutions, okay. But this can be done with the help of something called different colors, okay. This is not indicating directly, this will not display directly the pH value, but this will be indicated with the help of different colors, okay. So depending on the range of different 14 colors, okay, you will have a range of different 14 colors definitely, because pH value starts from 0 to 14, right? So you'll have 14 different colors, and from that 14 different colors you can definitely find out the pH value, okay. And this 0 to 14 range of colors will be I will just point out the main colors, okay. So there will be a red. In this red, you'll have a shade of red, okay. So from dark red to a very pale red, okay, dark to pale. So first will be red zone, then you will have a orange zone. Again, orange will be from dark to pale, okay. And after orange you will have yellow, and then you will have, of course it is dark to pale every time. Then you have a green. After green you have blue. After blue you will have indigo, and after indigo last you will have violet, okay. So these are the different colors, and in each category you will have dark to pale, dark to pale, dark to pale. So dark violet to pale violet, right? So these different colors are going to indicate the different range. So for example, red is indicating from 0 to 2, orange is from say 0, say you can say from 1 to 3, okay, that way, okay. So it will tell you about the range of the pH value, right? And the extreme left will tell you that it is strong acid. Extreme right is going to tell you it is strong base, right? And neutral will be somewhere on the green region. This will be neutral. these are going to be your weak bases, and these are going to be your weak acids. Okay, so depending on the color and whether the color is dark or a pale, okay, you can decide whether it is having a pH value in a particular range. Okay, so this is how this universal indicator helps you in not only identifying the nature of the solution, whether it is acidic or alkaline, but it can also tell you whether it is a strong acid or a weak acid, or a strong base or a weak base. Okay, so that's all about this pH value and indicators that you are supposed to know. And I will tell you that the pH value of some of the substances of your interest, that will also help you. Now suppose you take hydrochloric acid, HCl, okay, hydrochloric acid. Now the pH value normally of hydrochloric acid is 1, okay, and for sulfuric acid the pH value is 1.2. For acetic acid, which is also known as ethanoic acid, here you have the pH value of 2.9. okay, this way it goes. Okay, and if you want the pH value of some alkaline substances, then blood, human blood, okay, this is supposed to be having 7.3. It's not neutral but slightly alkaline in nature, because neutral means 7 has to be the pH value. So these are the pH values, right? pH values. So blood has a pH value of 7.3, and seawater, you know, seawater is highly alkaline because it contains a lot of salt, and seawater, the pH value is 8.5, and ammonium hydroxide, NH4OH, ammonium hydroxide has a pH value of 11.1. okay, and sodium hydroxide, NaOH, you know, that is also alkaline, and it has a pH value of 13.0. okay, so water of course has a pH value of 7, right? So this indicates that if the pH value is less than 7, all are going to be acidic in nature. If the pH value is greater than 7, they are going to be in alkaline category. And if the pH value happens to be 7, then it's a neutral substance or neutral solution. And the example of that is water. So that was all about this particular topic called pH value and indicator. And in the next session I may come up with some other concept, okay, from the same chapter. Till then, goodbye, take care all of you, see you.